Our present space technology rose to a new level with successful launch of Micro, Nano and Pico satellites, which are very economical. The dimensions of such satellites are of the order of few centimeters and their masses vary from 0.1 kilogram to 10 kilogram. As the inertia of such satellite is really small and any disturbance in the outer space could misalign the satellite from its mother satellite. It has to be noted that these micro-nano satellites work in a group. They form a cluster, performing tasks such as data collection and transmission to the mother satellite. Today I would be outlining you about the design, fabrication and characterization of cantilever-based microthruster for such satellites shown here. All satellites need thrusters for orbit adjustment, altitude control and to correct any existing misalignments. Various versions of microthrusters are in place. All have the same major components, which include reservoir, micropumps, reactor or boiling chamber, and nozzle, all packed in small confinement to achieve necessary thrust force. Here is the one such design on the right bottom. However, it is difficult to achieve required angular moment unless the nozzle is mounted on the outer edge of the satellite. In this study, a different approach is taken wherein a cantilever-based microthruster is developed which generates thrust force using hydrogen peroxide and catalyst as shown below. Looking into the chemistry of hydrogen peroxide, it decomposes exothermally in the presence of liquid catalyst to give out steam and oxygen, which when passes through the converging diverging nozzle generates sufficient necessary thrust at the exit of the nozzle. This nozzle is mounted on the solar panel of the satellite. Talking about the design constraints, we have two main considerations. One is the geometrical dimension and other the performance of the entire unit. As the thruster is made from silicon using MEMS fabrication technology, thus the size is restricted to 5 inches, which is essentially the size of the wafer available in market. But the actual size might be a lot lesser than the silicon wafer size, and that will only be determined after the design stage. Performance is predicted based on the thrust force developed and the reaction time to generate the thrust force. So in this study we have independent variables and dependent variables. Thrust force and the reaction time determines the geometry of the unit. The objective of the study is to identify the optimal physical dimensions of the nozzle and the cantilever used to design the thruster, satisfying the aforementioned design criteria. In this presentation, I restricted my talk to the design of microthruster. Here are the references. Thank you.